Okay, so start. Hoping the audio is working better this time. Change some settings. Uh, Everything's good. And if you have questions along the way in the chat, me through Remind, you can Edsby, and you can send them to me now. Checking those. Okay. So if the audio does happen to have a back, the streaming will be a good time. My apologies for the delay. I was busy in a meeting. Now that people found out that you can video chat with each other, show off changing back submarine, but yeah, our of section 4, which is working text form equation. I equals ax minus h squared plus k. So in the case of I equals ax minus h squared plus k, three letters of transformation. A is direction of opening. Positive A open upward, upwards U, and down is negative. See a couple of the audio is cutting out a bit. Let's see if I just tweak a few things here. Down and see if the audio's any better there. Let me know. And again, A is our direction of opening. Positive is up, negative is down. If A is a number between 0 and 1, or negative 0 and or negative 1 and 0, then you are making the graph widen and get kind of fat. Where if you have a number greater than 1, it's going to stretch out, make it skinny. The stretch expression. The h, remembering that it's negative h in the brackets there, so it flips back and forth, left and right, and so the negative sign in the brackets means that it does the opposite. So negative numbers move to the left, to the right. Positive numbers move to the left. That is the left right shift. And then k, final value, is the up down shift. Those are the translations that we've been looking at with our quadratic. So up, down, left, right, and then whether it's opening upwards or down, and if it's getting wider or it's getting narrower. A good resource to look at, flip over to the textbook here. Good resource here is in the textbook. The key concepts, just before the questions start, has a nice chart that tells you all the key information based on the a equals or y equals a x minus h squared plus k. So there's the basic concept, where the vertex is, what the axis of symmetry is, the stretch or compression factor, and then if the parabola, what the direction of opening is, the graph, what it should look like, and values that x and y may take. So this is a good summary of everything. And then it has a couple examples there of a stretch, compression, open up, open down, positive and negative x and y values for the vertex. So that should give you a good idea of what's coming in that. Give you a good idea of the type of situations that you're working with. So these are the key ideas that you should be able to kind of extrapolate and that from the equation. Now looking at some of the problems, again, if you guys have specific problems that you wanted me to take a look at, let me know and I will take those up. Again, email me or shoot me a message on Edsby, or send me a message in the chat here, and I will take those up. So for myself, I was thinking that doing number 1. So question number 1 here, just taking a quick look at one of those. I believe I had D and H. So if we take a look at, say, H for number 1, we have the equation in H is, copy it down here, y equals negative 3x plus 4 squared minus 2. And then what we want to do here is use that A, H, and K value to determine the various properties. First one is the vertex. The vertex is H and the K value. Again, that's negative H, so we flip the sign to negative 4 and negative. Vertex comes from those two values. The next part is the axis of symmetry. Call it the S. The axis of symmetry, x equals, and it's just the x value of the vertex, the negative 4. Every time x equals, and then it's just the x value of the vertex. The next portion is the stretch or compression. So in this case, the graph is being stretched by a factor of 3. Because that 3 is out front, 3 is greater than 1. The direction of opening in this case, the graph has a negative a value, thus it's opening downwards. That U shape is going to get flipped upside down. And then the values of x, the values of y. So the values of x, unless there's something specific in regards to the real world situation that's blocking x from being a certain number, like, x values are measuring the distance something has traveled. Well, it's not going to travel a negative distance, or it's not going to travel for a negative amount of time. Then there's no restrictions on x, so we usually just say x belongs to the real numbers, and the short form for that is x belongs to, and real numbers, kind of this scripted bold R, it's called. In the case of y, the graph's opening downwards, and the vertex then would be the highest point. So this would be the highest possible value of x here, negative 2. So y is less than or equal to negative 2. And that would be the case for y. All the time it's going to be based on the vertex. If it's opening up, it'll be greater than or equal to. Negative, it's going to be less than or equal to that number. So there's our y value. And again, x, unless there's a specific real world situation, the x values are always going to belong to the real numbers. Maybe try number 5. 5 looks like a good one. And again, unless you guys want a specific question to be taken up, I'll just pick some random ones here. So number 5, switch over here. Number 5 there says write an equation for the parabola with a vertex of 4, negative 1. and what else? Opening upwards, and a vertical compression of 0.3. So if I flip that back over to the note here, so number 5, there's the little bits of information I was given. So this tells us A is positive. This tells us A equals 0.3. This tells us that H equals -4 and H equals -4 and K equals -1. So there are the key values. There's our A, H, and K. So we have Y equals 0.3, our A value, which is positive, times X minus 4 in the brackets there, and square that minus 1. So the H again always switches that sign around when it's in the brackets. K is not. What else we got here? Try number 9. Take a look at number 9 here as well. So question number 9 is transitioning over. Number 9 says that the graph of y equals x squared is reflected in the x-axis, compressed vertically by a factor of 1/2, and then translated 2 units upward. Sketch the parabola and write its equation. So in this case here, we want to draw ourselves a quick little set of axes, and then I usually like to have that base parabola here. I usually like to just put a y equals x squared down just so I have a reference point. And then I make my changes from there. So the graph is reflected in the x-axis. So it's going to be reflected about the x-axis here. Just lightly dash that in. And then it is compressed vertically by a factor of 1/2 and then translated 2 units upward. So if I'm compressing it by 1/2, that means it's going to get wider and have a wider graph, something like this maybe. And then it's translated 2 units upwards, so that means all the points move up 2, maybe up to here at 2. So I can have a graph that looks something like this. And again, we're just doing a sketch, so it doesn't have to be perfect and exact. It's just a matter of getting something that is relatively in line with showing the different transformations that we've applied. So we've shown that it's wider, we've shown that we reflected it in x-axis, and we've also shown that we've shifted it up too. So that's the graph itself, and then the equation, well, it's downwards, so A is negative, and the factor of 1/2 our A value, so A is 1/2, so -1/2 is no horizontal shift, so no H value, so it's just 1/2 x squared plus 2 to show that we've shifted it 2 units upwards. So that there is our translation of the graph and a sketch of it. What else do we have? E13. And then we could try number 10 here as well. I had 10b, says find the equation of the parabola with the vertex -2 and 5 and a y-intercept of 1. So we have a vertex at -2 and 5, and then another point, y-intercept, so x is 0 and y is 1. Those are our 2 points that we have, and we can use these now in an equation to determine the various values that are missing. So y equals a x minus h squared plus k is our standard formula. So we sub in our h and k, and we also have an x and a y here. So our y value is 1. Our a value is what we're searching for because they never gave us one. Our h value here is x plus 2 squared. And then our k value, or sorry, not even x plus 2, it is or x value is 0. 0 plus 2. And our k value is 5. Simplify this out. 0 plus 2 is 2 squared. It's 4, so we have 4a squared, or a times 4, out of the order. And then rearranging this, we subtract the 5 from both sides, and we're left with negative 4a. Divide both sides by 4, and we're left with negative 1a. So that's our a value, and therefore the equation is y equals negative x plus 2 squared plus 5. Could put a negative 1 or just a negative sign. Both are perfectly acceptable. Do one more here, maybe just a one of the word problems here. Let's take a look at number 13. So in the case of number 13, have a baseball is batted at a height of 1 meter above the ground and reaches a maximum height of 33 meters at a horizontal distance of 4 meters. Determine an equation to model the path of the baseball. What is the height of the baseball once it's traveled the horizontal distance of 6 meters? And at what other horizontal distance is the baseball the same height as in part B? So we got a starting point of 1 meter off the ground. It's hit, and the max is 33 meters as a max height. That is at 4 meters. Switch back over. So starts 1 meter off the ground and 33 meter max at 4 meters. So very similar to the last problem that we did. We have a y-intercept at 0 and 1. And we have a vertex at 4 and 33. Should be for the horizontal distance and then the distance of 30. So if we want to create an equation for this to model it, then y equals a x minus h squared plus k. Sub in our values. 1 equals a 0 minus 4 squared plus 33. And then we calculate that out. Negative 4 squared is going to give us 16. So 16a plus 33. Subtract 33 from both sides. And then divide both sides by 16. And we're left with an a value of negative 2. Therefore, y equals negative 2x minus 4 squared plus 33 would be the equation that models the situation. And now, because we're hitting the ball, it's going to go up and down. There's going to be 2 points along the graph where it's going to be at 6 meters. There's 2 different points there. So in the part B, we want to know what are those 2 values, or what's the first value we get. So what we can do is we're looking for the horizontal distance, the x value. So we know the y value is 6. So we use our equation that we made. So 6 equals negative 2 x minus 4 squared is 33. And we just simplify that. Rearranging that, I'm going to move the 33 over, subtract from both sides. 6 minus 33 equals negative 2 x minus 4 squared. 6 minus 33 is going to give us negative 27, negative 2 x minus 4 squared. Now we have the negative 2 to get rid of, so that to the other side by dividing both sides by negative 2. Negative 27 divided by negative 2 equals x minus 4 squared. Negative 27 divided by negative 2 is going to give us positive 13.5 equals x minus 4 squared. So, as I mentioned before, when you take a square root of a number, there's actually 2 numbers that could possibly multiply to that. Square root of 4 is 2, because 2 times 2 is 4. But also, it could be negative 2, so it's plus or minus 2. The square root is technically plus or minus 2. So in this case here, when we take our square roots, square root of 13.5 and the square root of x minus 4 squared, square root of 13.5 is approximately 3.7. That's approximately x minus 4. They approximately get 3.7. But again, it's plus or minus 3.7, so both of those cases. There's actually 2 cases here. So x minus 4 equals 3.7, or x minus 4 could equal negative 3.7. So we solve both of these, and we have the answer for B and the answer for C all in one. First one here, we have x equals 0.7 plus 4, or 7.7. So at 7.7 meters, we have one of the cases, and the other case is x equals negative 3.7 plus 4. And that's going to give us 1.3 meters. So these are the 2 points that the graph equals, or the ball is at 6 meters. So when we're taking square roots, what you need to remember now is that when you take a square root, even though your calculator gives you one answer, there's 2 possible answers. There's always the negative version answer. So anytime you take a square root, plus or minus that possibility. And so that's what I did, and broke it up into 2 situations. There's our answer for B, there's our answer for C. So that's about it for today. I hope that helps. Again, if you have any other questions that you want me to take up for you, let me know. Edsby, email, mind, whatever works for you. I'll go back over the audio for this. If it's all choppy, then I made a backup copy on the computer here, so I can upload that as a replacement. Anyways, have a good day, and